Every time I come back from this conference, my wife asks me the same question, how'd it go? And I say, man, those guys are getting older and older. And of course, I always say, well, it beats the alternative. So I'm here today to give you the runaround. Runaround is a new game that we've brought to market with Kate Jones of KDON, and you can go upstairs and see it and buy it. It's a game that I think Martin Gardner would have liked, and I think it's also a game that Tom Rogers would have liked. And to do a corollary to Conway's principle, if you want to find out what mathematics is, try developing a game. You'll quickly get into probability and you'll quickly get into some real math. So let's get on to the game. The idea is to find runs. We have 10 digits. Imagine them laid out in a sequence. And voila, there's a run, 6, 7, 8. The run is indicated by a smiley face. The blank tiles are not important for our current purpose. Now, runs can go in either direction, ascending or descending, left to right, right to left. This game can be played in China, Japan, and Israel without any bias. But be careful when you're doing this, that's not a run, okay? And it's not a run because 6 does not come between 4 and 5. So you have to be a little bit careful when you're doing this with 8-year-olds to make sure they understand what a run is. Now you can have multiple runs in this array of 10. Here we have 7, 8, 9, and 2, 3, 4. 2 runs, 2 smiley faces. You could have 3 runs, right? And at this point someone says, but that's the most you could have because you only have 10 tiles. And you'd be wrong, because you could have a run of 4, 2, 3, 4, 5, and that counts as 2 runs, 2, 3, 4, and 3, 4, 5. So you get 2 smiley faces for that. Here's a run of 5, and that counts as 3 runs, 0, 1, 2, 1, 2, 3, 2, 3, 4. So you get the idea that with multiple runs, it gets a little more interesting. Now the numbers wrap around. 0 can be the lowest number, 0, 1, 2, that's a run. But 8, 9, 0 is also a run, because 0 is also the highest number. Now once you let the numbers wrap around like that, you have some new runs. You have 9, 0, 1, of course. But if 9, 0, 1 is a run, then so is 1, 0, 9, because once again, the runs can go in either direction. So number wraparound gives you some new runs. And now we add the additional feature that the rows can wrap around. So here you have 6, 7, 8, which is a run because it goes around the horn. And of course, our friend 1, 0, 9 is also a run. And here we have a run of 4, 9, 0, 1, 2. That counts as 2 smiley faces. So you can see that with the combination of runs going in both directions with number wraparound and row wraparound, try to say that really fast, you have lots of possibilities. How many runs do you see here?
10.
Come on, we only have 6 minutes.
20.
10. There's only 10 tiles. I see 4, okay? 5, 6, 7, and then 8, 9, 0, 1, 2 is a run of 5, so that counts as 3, okay? So the game is maybe a little more difficult than it first appears. You start out with something very simple, but it becomes complicated pretty quickly, and questions come up. For example, if you put the 10 tiles down randomly, how many times will you get no runs of 3? How many times will you get exactly 1? How many times will you get more than 1? And so on. Now, it's easy to do this exhaustively. There's only 3,628,800 arrangements, which for this audience is a small number. My first question was, have the mathematicians already solved this? I enlisted the help of 2 colleagues, Paul Campbell, a math professor at Beloit, and Ashish Vikram, a very good programmer in Bangalore. The three of us worked on this problem for a while, and we've come up with the answer that there's exactly one run about 17% of the time, and more than one run about 3% of the time. So what came out of this? We have the game, of course, which is premiering this week. Paul Campbell managed to get enough mathematics out of this to submit a paper to the Journal of Integer Sequences. We were able to get 7 new sequences added to the online Encyclopedia of Integer Sequences. And I was working this problem. I have now solved analytically all of the cases except 4, 3, and 2. Though that remains an open problem. What about Paralel Elevens? Well, Runaround employs 4 of these rows, and there are various ways to play the game. As an added spice, we added an 11th tile, which is a joker. We're not saying that's the right way, the wrong way, but if there's a joker, it's the con way. One thing about your gift bag, every one of you is getting a copy, the most recent copy of the UMAP Journal, which is published by COMAP. This is something you should all be looking at if you're interested in mathematics education. And in that journal, there is an article on Bayes' theorem, use of Bayes' theorem for medical diagnostics. We have a very nice new result there, which we think could cut diagnostic tests by half, just by using some very simple mathematics. I encourage you to read that paper in the journal, and I absolutely forbid you to write your congressman about that once you've read it, okay? You're not allowed to do that. Thank you.